geometry students, we're in section 5.7. Now we're going to do example 3, and we're going to target a concept called Pythagorean triples. Pythagorean triples. And I'm going to circle this right here. I do want to point this out to you. Pythagorean obviously has to do with the right triangle, side lengths. The key to this is very, very important. The numbers, the side lengths, are non-zero whole numbers. So I'm going to circle that. That's what we're looking for. If you end up with 3 sides of a right triangle with 3 whole numbers, then you have a Pythagorean triple. Okay? That's the key. It can't be a decimal, can't be a fraction, can't be the square root of a number that's not a perfect square. It's got to end up being a whole number that on each side. So both legs and the hypotenuse must be whole numbers. Okay, so let's get into example 3. Find the missing side lengths. We've got to do that first. And then we've got to tell if the side lengths form a Pythagorean triple. And they want us to explain it. We'll just do that verbally. Don't worry about writing that. Okay, so remember these are legs. So we've got A, here's B. The hypotenuse is always C. So we're going to say, okay, C squared equals A squared plus B squared. Awesome. Go ahead and square your numbers. We're going to end up with 225 is equal to A squared plus 144. Then take away 144 from each side. And let's see here, 2, 1, 12. So it looks like we're going to end up with 81 equals A squared. And then, of course, to undo a square, you're going to take the square root of each side, and you're going to end up with A equaling 9. Now that we know A equals 9, look at your numbers, 9, 12, 15. Because they're all whole numbers, we have a Pythagorean triple. Okay? So that's what we're looking for is, they're going to give you 2 sides, you figure out the third side, or it could be a leg, it could be the hypotenuse. You figure it out, then assess. If you see all 3 are whole numbers, it's a Pythagorean triple. If all 3 are not whole numbers, it's not a Pythagorean triple. Okay? So let's look at B. B is very similar. They gave us both legs. And we have to find the hypotenuse. So it looks like we got 81 plus 225 is equal to C squared. Looks like we've got 306 equals C squared. And we got to take the square root of each side. And so if you do the square root in your calculator, you're going to get a decimal. Is what's going to end up happening. So practice that really quick. Do the square root, and to access the square root, you would hit the second button, second, and then x squared, and that'll access the square root sign, and then plug in 306. And you'll see you're going to end up with a decimal around 17.5. So it looks like C is about 17.5. So 17.5 is not a whole number, so we do not have we'll say it's not a PT, not a Pythagorean triple. Not this time, okay? Remember, if we want to simplify the square root of 306, we may encounter that in the future where they don't want us to do a decimal. They want us in simplest radical form. Then what we'd have to do is try and find a factor, a perfect square factor of 306. You could try it in your calculator, do 306 divided by 4. Nope, that doesn't go. 306 divided by 9. Nope. I did 309 divided by 9. I said what I was, mistyped it, and that goes. We'll have the square root of 9 times the square root of 34, and that will translate, because the square root of 9 is exactly 3, that the simplest form would be 3 times the square root of 34, or decimal form, 17.5. So this is the approximation, okay, and this is the exact reduced answer. Okay? All right, good job on that. If you have any questions, write those down and we're going to talk about them in class tomorrow.